Alright guys, welcome to the second video. We are doing Newton's second law. We want to answer this question and help you prepare for the exam. I know grade 11 is about to write, so this video will be uploaded as soon as possible. Now, with Newton's second law, of course, we'll expect you to calculate tension. Expect to get at least 2 blocks attached by a string or a rope, you understand? So now, of course, maybe the first question will say state Newton's second law. Right, you will state it. Please know Newton's second law. Now, we just jump straight to drawing the free body diagram for the 4 kg block. Now, when you talk about a free body diagram, you must draw it in terms of a dot. I don't want to see a block. When a free body diagram, we talk about a dot. And then we identify all the forces that act on the 4 kg block. Let's analyze the diagram. The 4 kg block is on an incline. It's inclined at a certain angle of 30 degrees. The 8 kg block, it's on a horizontal surface. You understand? Both blocks are on a rough surface, hence you're giving the coefficient of both of them to be 0.1. You understand? But mostly, when you get the frictions, expect the heavy block to have more friction and the less block to have less friction. When you draw a free body diagram, we look at this 4 kg block. Draw it the way it is. Put it on an incline. Put the dot here. I hope you can see my dot there. The first force is the normal force. And it's always perpendicular to the surface where your object is. So we'll have a normal going that side. Label it as F normal. You understand? On a horizontal surface, gravity balances the normal force. But on an incline, the normal force is balanced by the component of gravity, which we call the perpendicular component. Now, it's going to go, right? This is like this. Then this one, we call it FG perpendicular. That's the one that balances the normal force. You understand? Gravity goes down straight. This is your gravity, FG, going down. Another component of gravity is FG parallel, and I want to emphasize this. Whether your object is going up or down, whether the motion of the object is up the incline or down the incline, FG parallel always goes down. Then, FG parallel, here is it. It's going down the incline. You understand? Then, because they're on a rough surface, we expect friction to be there. And friction opposes the motion. Currently, our motion is going where? Down. Which means friction is going up, it's opposing the motion. You will have then friction going there. Now the 4 kg block is attached to another 8 kg block. That means we have tension in the string, you understand? And what happens is that the 4 kg block is going down, pulling 8 kg down. But 8 kg is resisting and it's pulling 4 kg up. That's Newton's third law. When you push me, I push you back with the same force but in an opposite direction. Now, we then say that we will have T1 here, 8 kg pulling 4 kg up. And then we have T2, 4 kg pulling 8 kg down. Both forces, T1 and T2, they are equal, they're in the same string, you understand? Then, where is T1 going? It's opposing the motion. Therefore, on the free body diagram, we show us that this is T1. That's it. This is the free body diagram of 4 kg block. You understand? Now, all these forces will go on our F net equals to MA when we want to do the calculations for the tension. We also need to do the free body diagram for the 8 kg block. Let's look at 8 kg block. So this is for the 4 kg block. Let's look at for the 8 kg block. 8 kg is on a horizontal surface. So when we draw it, this is the free body diagram now on that line. I always draw the vertical first, normal, followed by FG. Now because it's on a horizontal surface, normal is balanced by FG. There are no components there, don't confuse it. Just because you see an incline here does not mean that the 8 kg block is on an incline. It's not. Then it's balanced by the FG. There are no components there, no FG perpendicular or parallel. Now, T2 is the one pulling our 8 kg down. You understand? Then it goes there, T2. But 8 kg is on a rough surface. There is friction there. We indicated going that side. Friction is always opposing the motion. We are done with the free body diagram for 8 kg and for 4 kg. When we go to calculate tension, we're going to use simultaneous equation, solving acceleration first, then getting tension. But we need F net equals to ma. That's Newton's second law. We are interested on all the forces that contribute to the motion, horizontal forces. Those forces must be parallel to the surface of the object, not vertical forces, only horizontal forces.